Padmashree Warrior is an outstanding role model and inspiration. She gave the opening keynote at WIDS 2019 and energized us all with her vision for what she calls the data decade, with businesses that will be built or completely re-architected around data science, AI, and blockchain innovations. Padmashree spoke about applications such as autonomous vehicles, improvements in healthcare, and others, and about the importance of proactively addressing unintended consequences. Padmashree's quote from this talk still sticks to me: "Open doors and go through them." Padmashree recently founded a startup called Fable, and I am sure that she will be a very successful trailblazer in this new endeavor as she has been in her previous roles.
Thank you. Thank you. Good morning. And very warm welcome to everybody watching on live stream. It's indeed a great pleasure for me to have this opportunity to speak to all of you today. It's personally exciting for me as a woman and a technical woman to see a room full of highly accomplished, very talented women here and everyone watching online. And thank you, Dean Widom, for traveling around the world, inspiring so many women, wonderful stories. Let's just give her another round of applause. Thank you. So what better way to kick off the day than to talk about what I term the data decade. I truly believe this next 10 years, if not more, many businesses will be created using data as a foundation. So until recently, I was the chief executive officer and the chief development officer for one such company called NEO. NEO is building electric vehicles using a lot of data and data science to develop autonomous driving technology, and we launched few vehicles in China already. We took the company public recently, and I left the company to be thinking about my next startup, which I will announce hopefully in the next few months or so. So with that, one of the assertions I want to make today is really mega businesses going forward will be built around innovations that will leverage data, and here I mean everything from database architectures to how we create platforms to collect the data in the right formats so that they can be useful, and applying then machine learning and AI to those data sets. And I also believe blockchain will play a new role and an interesting role going forward in how many of the new businesses of the future will be defined. And this, by the way, this transformation, I fundamentally believe will require complete architectural redefinition all the way from service delivery going to silicon, which will disrupt many of the existing businesses that exist today and also pave the way for new entrants to actually start companies and grow them to be huge businesses going forward. And if you think back retrospectively, this is not so much different in how we saw the internet, the evolution and the adoption of internet give rise to whole new sets of architectures, and more recently, the mobile internet and what it did to the industry. So if we look back and double click on that, 10, 20 years ago, probably 25 years or so ago, when the internet started to become a massively adopted platform, industry then totally focused on how do we get billions of people online. With that, there were devices and device companies that became very successful, and desktop computers followed by laptop computers became the device at that time. That was the most popularly used device everywhere. In fact, Microsoft, Bill Gates famously said a PC on every person's desk back then. And then also on the infrastructure side, we saw companies that were building storage solutions, premise-based networking solutions, which Cisco was where I was Chief Technology and Strategy Officer before I went to NEO. Companies like this started to build premise-based solutions. The CPU architecture was the mainstream architecture for the silicon and the processing power. QWERTY keyboard was the main user interface, right? And IBM was one of the primary proponents of this types of architecture. And the solutions that we sold in businesses back there primarily were business solutions and IT services associated with that. And the business model was licensing software. Enterprise was where most of the advanced technology resided, and many of the solutions had to do with productivity in the office. Then that shifted to where we saw in the last 10 years, the last decade was really about the mobile internet. And we saw a transformation and a shift from desktop computers to smartphones. Today, we carry more compute power in our pockets and our handbags and purses than anywhere else. And that actually gave, again, another shift from premise-based to cloud-based solutions. A lot of the compute shifted into actually a very distributed architectures. And the silicon architecture changed to where we had to focus more on power management and low power compute architectures, and more recently to the GPU, where you have a lot more computing power to do very high intense graphics on a very small platform like the mobile platform. With that, the user interface also shifted from a QWERTY keyboard to a touch screen, right? Many of our kids growing up now don't really need to know how to type because they use a touch screen for everything. They just do things in a very different way. With that, we also saw how the services shifted into now mobile apps and subscription-based cloud services. We pay on demand and we pay as we use the services that we want to use. Companies like Uber, Lyft, Airbnb, all these companies actually were born as mobile native companies. And so that's because of the rise of the mobile internet. We had to redefine the entire stack and all of the solutions associated with that. Digital advertising actually started to become the mainstream business. Before the invention of the mobile and search, digital advertising didn't exist. It was actually all advertising that was done on television and paper. So that whole industry got created because of this. And consumers, as consumers, we started to use much more powerful technology than we were using at work. And search and social became the massive applications and gave birth to many, many large cap companies in this last decade. So what about the future? Where will we go? Which is what this room is going to create going forward. So in the future, we will be focused not just necessarily getting people online, and the mobile internet was always keeping people always online. We now have to focus on how do we keep people safely online. So huge emphasis on privacy. And as data scientists, we have the responsibility to make sure we are collecting data in an ethical manner and using that data in a responsible way. So focus is going to shift again. And AI is really going to be the architecture that will drive everything from the service architecture to the silicon architecture, like I said. We'll see, again, a device shift, mostly into wearables and smart objects, tiny objects that are going to be distributed, which will have a lot of intelligence at the edge, going back into the cloud. TPU will probably emerge as a mainstream architecture for processing. Voice will become the primary interface. It kind of already has started to make that shift. We'll see more of that. Applications will be much more on demand, microservices that we will be using different sets of services that we'll need in a combination way. Data commerce, I think, will emerge in how we actually apply commerce to data. Data people will start treating as their property. There's interesting companies actually forming through how do people own their data much more in the future. Subscription will become the primary business model for how people will pay for these services. Consumer internet and enterprise-focused solutions will start to blend together. And this kind of is already happening, which will become much more mainstream going forward. Data, AI, and blockchain, as I said, will become the killer technologies that will drive the future. So this is kind of how I see the future evolving. So why do I believe this? If we look back for 2018, I often believe actually we have to look at what is happening in the last year in order to predict where the future is going. And this is a lot of data on the slide, but I'll just highlight a few things. If you kind of look at, there were some foundational shifts that happened in 2018. Probably first and foremost, 2018 we'll remember as the year that social changed forever, right? Now, all the concerns people started to have about the veracity of news and what we are seeing and reading as news, the accuracy of it, on all different platforms, by the way, not just Facebook, but TV, digital, print. This started us as consumers to become much more aware of having more accurate, validated data, not just something that people were passing on as news, right? So this is probably one of the, I would say, foundational shifts that happened in 2018. Social media business practices started to get a lot more scrutiny. We saw hearings in Congress where there is interest from regulators in understanding what is happening on these social platforms. I think this is all a beginning of heightened awareness amongst users around the value of their data. People started to realize that the data that they're sharing is their data and they need to have certain rights about that. I think it's an important point, and hopefully we'll discuss what role policy and regulation plays in data as scientists as we think about algorithms to apply to this data. High quality streaming video, I'm on the board of Microsoft and I'm on the board of Spotify, a very interesting company. So the rise of Spotify and Netflix have shown us that as users, we're willing to pay for high quality streaming content. It's another interesting way to think about what kind of services people are willing to pay for in the future. As I mentioned, voice, and today AI-assisted assistants, as we call them, whether it's Alexa or Cortana or Google Now, these things are beginning to become more mainstream, and I think they will become much more important going forward. And by the way, the concerning aspects of technologies, now there is increasing evidence pointing out to some of the negative effects of technology, which many of us who worked in the mobile industry or worked on building social platforms never thought or never anticipated which would happen. We should pay more attention to that, and I encourage all of us to actually go deeper and understand this research. Some of you may be doing research in this area. This is something I've been studying a lot. So I think that's something that's important. 2018 will also be remembered as a year that China's economy slowed dramatically, which has drastic effects globally. And the US-China tensions are also beginning to affect the markets, right? In addition to that, there is what I term techno-nationalism and data nationalism, where the data resides in different countries that are going to have implications to all of us. So this is sort of my one-page summary of the important things that I saw happen relating to technology and data in 2018. So my predictions for this year and going forward, we'll begin to see the emergence of a few killer apps on blockchain. I think, unfortunately, last few years, blockchain has sort of become a technology that was misunderstood and perhaps misapplied, and I think this year we'll start to see some real applications for it. This is my field, autonomous car 3.0, which I talk about the next generation vehicle, which is really an AI platform. It'll become a next generation engagement platform for content, commerce, and productivity going forward in the future. As I mentioned, users are becoming much more aware of the importance of data, and we're beginning to talk about data abduction, data privacy, data trafficking, data brokerage, how some of the good things of data could actually have negative implications. So as scientists, as I said, we should pay more attention to this. Increased demand for curated content, health tech. Applying technology into healthcare industry is becoming a domain and a distinctive segment and a vertical by itself, and I'm very excited to see that happen. We will start to see actually new platforms emerge, perhaps, for very specialized communities. It started off in gaming. Gamers, any gamers in the room? Anyone into gaming? Few of you. I think gaming has always had a definitive platform on its own, and we perhaps will see more of these specialized communities that will be built in distinctive platforms. Another opportunity to do startups around this. China, I believe, will start to accelerate their intended goal of becoming a STEM leader in the world, and this is something that's going to be important for us, and especially in the United States, we should be paying very special attention to this and make sure we're not falling behind as a nation in our leadership. And then core business growth for certain large platform companies will begin to slow as they search where their next set of growth is going to come from. With that, if you then step back and say, so where will the opportunities be? Specifically for the data science, many of the applications that I see will come with data science becoming the front and center. So in this graph, I've pictorially tried to show where I see the data science applications, and by the way, I'm using data science in a very broad sense of the word here. They started off with personalization. Initially, it was primarily Netflix, Amazon, companies like this that were using data science primarily as a recommendation engine for us. You like this book, so maybe you'll like this other book. You watch this movie, perhaps you'll like this TV show, right? That's sort of where data science applications was. And then it moved to advertising. And as I said, there's pluses and minuses of how data is used for advertising. Then it began to creep into what I term connected robotics. So things like autonomous driving, not just for cars, but for drones, for delivery vehicles. It's kind of beginning to shift there, where it becomes a challenge now. Now we are using data in a very different way to control not just recommendations, but control very safety critical machinery that takes people. So a car weighs a ton. And we are sitting in a vehicle and we're collecting data through cameras and sensors, and we are operating very mission critical equipment with this. So the complexity becomes much more than a simple recommendation engine that's telling us which book we may like or dislike, right? And so as you go along the y-axis, the complexity of what data and data science has to do and the criticality of which it affects human lives becomes much more important. Then go one step further, health tech. Now we have to be really careful about the reliability of the recommendations we're making. If we're using data to perhaps assist a doctor to do early diagnosis, right? Now it could be a very life-threatening situation. So we have to take much more responsibility to focus on the reliability of the algorithms and the applications therein. And then going forward, as I said, perhaps there'll be new platforms that we haven't even thought about. On the x-axis, I'm kind of giving examples of how different companies are focusing in this area and where new companies, as I said, might emerge from it. So I think this is as I was putting this slide together last night, and I was working on based off of the research that I was doing for the last 6-7 months or so, I was actually thinking how multidisciplinary this future is going to be, how we have to really combine science with mechanical engineering, electrical engineering, medical schools, and how we deploy all of these solutions. So I think this is, even in academia, it's going to shift the way we would have to teach students and how we bring students on board with all of this. So let me give you specific examples of what I mean by this, how I mean data is actually becoming front and center in very different industries that never were considered data-driven industries. The auto industry, a 125-year-old industry, where cars were pretty much built the same way, I would say for the last 50, 60 years or so, is changing dramatically, right? And we are seeing the beginning of what I term car 3.0. If you look at the auto industry, you can think of roughly the industry's growth and innovation in 3 different phases. The first phase of the auto industry, from about 1900s to 1970s, was primarily about mechanical engineering innovation. People really focused on making the car lighter, putting the components together for faster acceleration, better performance, smoother ride. In the last 30 years, from 1970s till about 2000s, it shifted to electronics and electrical systems, where the terms such as mechatronics was invented by the industry. I would say the next 10, 30 years, the car is really a computer. So if you think about that, and when a car drives itself, and we as human beings are not driving the vehicle anymore, we now have 2 to 3 hours of our time freed up. So then the car becomes an engagement platform. If you're not driving, and if you have 2 to 3 hours of your time where you're sitting in your living room, essentially that's moving you, what would you do with that time? You would perhaps work, might shop, you might entertain yourself, right? So this becomes the next big engagement platform, just as the TV was an engagement platform, and it then shifted to where the PC was the engagement platform, and today it's a smartphone. You go anywhere. I just came back from a long trip to India, and I was noticing on the airport, on the flight, everybody was looking at their smartphone. That is the screen that engages all of us, and someday it'll be the screens inside the car. Right, that becomes a huge, huge opportunity. And AI and data are very much central to this transformation. So that's one example. The car of tomorrow or the future vehicle is not really a car anymore. It's a robot. It has many, many different sensors in it. It has at least 2 to 3 supercompute engines inside it. It's a service. It's something that we get when we want. We call a Uber when we want or a Lyft when we want, right? So transportation as a service. It is a battery. It's essentially a source of energy that we charge and we deplete as we please. And it's a data center. It actually has many different servers, both in the cloud and embedded inside the vehicle. So it's fundamentally a very different platform. Goes back to my point about everything changes from the service delivery architecture all the way to the silicon. The type of silicon we use in building these kinds of highly automated machines is very different. This concept never existed in the auto industry. So it's fascinating to think about the auto industry, which was primarily a mechanical engineering industry, shift to becoming a data industry. It's all about data. We collect and deploy petabytes of data continuously from a fully autonomous vehicle. So the networks that actually pull all this data from the car into the cloud have to be much broader. The pipe has to be much broader. And then how we deal with this data pertaining to the sensors that are keeping track of the car, data pertaining to what the users inside the car are doing, and data pertaining to the environment that the car is in. Where is it driving? What are the traffic patterns? It's different types of data that needs to be segmented and analyzed in a very different way, right? So that's one example of how a very old industry, an industry that we took for granted for the last 100 years or so, is fundamentally going to look very differently in the next 10 years. And this journey is already underway, right? The next industry that I predict will change fundamentally is healthcare. Broadly, healthcare, I mean, it's a massive industry. Global healthcare expenditures in 2018 are roughly 10% of the world GDP. Imagine that. So much money is spent worldwide. And it's expected to rise, by the way, to about $10 trillion by 2022 globally. It makes the auto industry look tiny. It makes the smartphone industry look like it's minuscule. Right? Massive opportunity in the healthcare system. And if you study, and I've been reading up a lot in this industry last couple of months since I've left NEO, a lot of inefficiencies that we can improve by applying data in a very smart way. And along with this, life expectancy is expected to climb. Today, the number of people over 65 globally is more than 650 million, roughly. It's about 12% of the total population. So we're getting older and we're living longer, which is good news. We're staying healthier, right? So we're going to look for ways to focus more on wellness rather than sick care. So this is actually going to shift the focus from taking care of the sick to allowing us to stay healthy longer to delivering personalized healthcare. Right? And if you take that massive healthcare industry and segment how much of that is health tech, it's about 280 billion by 2021. So even that part of it is still very big as an industry. A lot of opportunity here. And so what role will data science play in this? Health informatics, really collecting information, everything from insurance data to data pertaining to patients, and by the way, a lot of publicly available information. If there's a smart way to aggregate all this data and then apply science to it, we could actually improve efficiencies in this industry by many orders of magnitude. And a lot of it in health industry is actually behavior management. It's actually non-clinical factors, such as what we eat, how much do we exercise, the environmental factors that are causing us, for example, stress perhaps. How do we manage that stress in a different way? How do we know what's causing us stress? These are all behavioral things that are very non-clinical. So a little different perspective on what this data means and how we can help users understand their behaviors and therefore be responsible for their own behaviors in a different way. Massive opportunity here. And then, of course, chronic disease management. I think already a lot of emphasis on diseases like diabetes, perhaps going into high blood pressure. Medication management, actually offering people's ways to remember to take their medication. Lots of different ways we can apply technology here, and then nutrition and exercise coaching through AI agents, right? So these are just low-hanging fruit, in my opinion, but I think healthcare industry is just where perhaps the auto industry was about 5-6 years ago in its own transformation. So brings me to, as we increase along the complexity on the y-axis of the chart I showed, we as scientists have the responsibility to move from hype, right? There's a lot of hype around data, to actual reality in solving some very complex issues. And so that's what the focus of what we deliver has to be, because the implications of applying data, machine learning, and AI into some of these problems are actually fairly significant and serious. On the left-hand side, I've listed some of the changes that are changing the two industries that I picked as examples. One is broadly what I call connected robotics, which auto is a part of, and connected health or health tech, right? And if you can think of the applications or the challenges, it's how do we treat this data? How do we make sure that there is secure way of accessing and retaining this data? What kind of things that we have to worry about that will help users feel that their privacy is protected? What role does regulation play? How do we make sure the algorithms are going to always be reliable in being able to predict? These are not simple things to address, and therein lies the challenge that we as scientists have to focus on. And then shifting gears a little bit, how do we fix the mess that we created? If you kind of read the emerging body of research that's bubbling up right now, it's actually pretty worrisome, right? The negative effects of social media and what that means, and addiction to technology and screen time, and the effect this is having on our children. What does that mean? How do we reverse some of that? How can we make something positive and take the negative effects of this out? This is a big, big challenge for all of us, right? So you can read the research that's out there. So my message to all of us, and include myself in this, is as scientists, we have to proactively address the potential unintended consequences of some of the solutions that we will be developing, right? I think we didn't do as good a job, I would say, in the last 2 decades, and perhaps we didn't know what these things could be. Sometimes it's difficult to anticipate, but this is another area where actually data can help us. We should be able to do trials more and understand potentially what could be some negative aspects of applying this technology. So that's something that I want to leave us all to be thinking about. I know I'm running out of time here, but I couldn't finish this talk without really talking about the role women would play as leaders in this next decade. So I started my career almost 30 years ago as an engineer in the tech industry, and we never had rooms like this. I went to a school where there were 5 women out of 250 students in engineering in IIT in New Delhi, and I want to change that. And it's my personal commitment to change all of that, and this is why I am here today. I think we all have a role to play in this. I'm here as much to learn as I am here to offer advice through what I went through. One of the first things I will say that helped my career, that I hope will help all of yours, is to make sure you're opening the doors for yourself. And when you see a door open, go through that. This is how you find opportunities. People always ask me, I had a great job at Cisco. I was Chief Technology and Strategy Officer. I left the company to go join an unknown startup called NEO, building electric autonomous vehicles. I had never worked in the auto industry before. I grew up in the tech industry, and last 3 years I spent building cars. And I left again to go do something different. This is how I have become, I think, we're much more versatile in what I've learned. Sometimes as women, we hold ourselves back. So I encourage all of you to really push through open doors and go see what's on the other side. You will never know what exciting opportunities there are waiting for you unless you go through those doors. The second thing is an advice that I got from my dad when I went off to study engineering. He said to me, keep your eyes on the stars and feet on the ground. What does that mean? I asked him, what does that mean? That doesn't even make any sense, Dad. He said, well, that means you should have a grand vision, but you should have a plan to get there. Focus on the details. As you're planning your careers out or you're building your companies, make sure you have a big, broad vision, but make sure there's always a detailed execution plan to get there. This is something I carry with me all my life. And the last thing I will say is to learn to work across boundaries. Increasingly, our world is becoming much more multidisciplinary. The solutions that we have to create, how we collect data, how we apply data, is going to be radically different if you think about the connected robotics industry or healthcare industry. We have to learn to talk to people from different fields. Even when I went to NEO, had to learn the concepts of building a car. I'm not a mechanical engineer. I really had to sit with the mechanical engineers and understand how data needs to be applied into connecting a system that's moving constantly all the time. So this is going to become very, very important to all of us. So let's make this next decade the WIDS decade, right? The Women in the Data Science decade. I think we started off by saying educate, inspire, and support, and that's what we will do. And we as leaders will have a huge opportunity to create many, many mega businesses that are going to use data as at the foundation of it. With that, thank you so much for inviting me.